Hello again, everyone. Today's video is all about absolute value functions. So let's start off with more basic knowledge of what is the absolute value of a number, right? If I ask you to take the absolute value, let's say, of 5, what does that even mean? Well, absolute value is the distance that a number is away from 0. And since we're talking about distance, if you remember from geometry, distance is always measured in positive units. So if I asked you, if we go back to that example, the absolute value of 5, well, if we think about our number line, the number 5 is 5 units away from 0. That's why the answer is 5. Similar concept that if I asked you the absolute value of -5, you would also tell me that it is 5, because -5 is, again, 5 units away from 0. So if we take this idea, which is very linear, and then we think about it in terms of an x and y axis, we start creating a function out of this. Let's say that we take the absolute value, we'll fill in the chart here, of a -3. So the absolute value of -3 is 3. I'll fill in the chart and then we'll go ahead and graph it. The absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of +1 is 1. Absolute value of +2 is 2. And absolute value of +3 is 3. So let's take a look now and see if we can plot these coordinates to take a look at the graph. So -3, 3. So -3, 3. And we'll be putting a dot. -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. And 3, 3. So if we take a look here, and if I looked at any one of the values in between, so say like -2.5, -1.25, any number in between, if I find the absolute value of that, I'm going to see this linear relationship. All right, and I'm going to see a linear relationship again going over in this negative direction as well. And if we think about going out to the extremes of the graph, the end behaviors, if we continue past our graph is only -5 to +5, we would see that this pattern would continue. So we can go ahead and put the arrows on the end of each graph. So this leads us down now to what is the domain and range of this absolute value function. Since we do, again, have the arrows on both ends, that means that our domain values, our x values, our inputs, however many words we can say for the same thing, right? Our domain would be -infinity to +infinity. So we can put a parenthesis around this, -infinity to +infinity. And then our range, if we're thinking about the range of this function, we're looking for the lowest possible y value, which happens to be 0, and it is included. So I'm going to put square bracket there, 0. And if I look at the highest y value, that's going to be, again, +infinity. And infinity always has a parenthesis with it. So we can see that our absolute value graph has this V shape to it that continues on in both directions, -infinity to +infinity, hence that's the domain. And our range, again, here happens to be 0, again, to +infinity, because we're looking at those y values. This is just the basics of absolute value functions. As we continue on in this unit, we'll start doing what are called transformations of these graphs. So we'll start adding and subtracting a bunch of different values onto our parent function here, absolute value of x, to see how those transformations work. Thank you so much for watching, and I'll catch you next time.